power is 1. B to the first power is B. B to the y power is B to the y power. And inverses undo each other. Let me just erase that here. So then at least if someone wanted to fill this in, they could. All right, so this is what I really consider properties of logs. So I want you to remember all your exponential properties. So for example, I'm just going to write this on another piece of paper so that someone else watching the video could see it. Do you remember what the property is? If you take x cubed and you multiply by x to the 7th, what you get for exponential properties? What do you get if you multiply these together? X to the 10th. So what was the rule for exponents? We added them together. The product property of logs similarly goes along with that exponential property, right? Because a log and an exponent are inverses of each other. So if you are taking a log and there's a product inside, so r times s, you're actually allowed to break this up into the log base b of r plus the log base b of s. So you might ask, why would you ever break a log up? Usually we're going to have to start over here on the right and we're going to simplify it and write it back as one log. So we use this property when we want to simplify an expression so that we only have one log to deal with in the expression. So here, if I'm multiplying these two things in the log, I can separate them out. The log base 6 of 3 plus the log base 6 of 7. In this problem, there's no real point, like why would you want to write this as two separate logs? But we're going to see times where you could actually simplify. Like if this had been the log base 6 of 6, then this part right here would just be equal to 1. So sometimes it helps you simplify the overall problem. So it's important to know if you're multiplying inside a log, you're allowed to add. Just like if you're multiplying exponents, you're allowed to add the exponents together. Same is true for the quotient property. So what was the rule for exponents? If I had x to the 7th and I was dividing by x cubed, what was the quotient property for exponents? What do you do? How do I simplify this? What do I do with the 7 and the 3? Subtract, right? 7 minus 3 is 4. Well, guess what? The quotient property for logs is to subtract. So I can write this out as the log base b of r minus the log base b of s. So right now it kind of seems pointless, but we are going to learn how to simplify logs to solve equations. So it's kind of an intermediate step. So the log base 4 of 2 minus the log base 4 of 3. So I'm just writing it out as two separate logs. The property in and of itself is really useless. You really need it when you're solving something. So we're going to need these on the next kind of task. And then the power property is really important. You're going to see that a lot. So if you are raising something, a variable or a number, to a power inside the log, the power property actually says that you can take the power down front and multiply the log by that power. So instead of r to the c power, I have c log base b of r's. So it allows you to evaluate the log and use the exponent as a coefficient. And the reason for that is basically this product property up here. So if I had, you don't have to write this down, but if I had the log base b of r cubed, this power property tells me I have 3 of them then, because I'm bringing the 3 down front as a coefficient. Isn't r cubed the same as writing r times r times r? And didn't we just learn that the product property, you're allowed to write them as 3 separate logs? Right? So whether I use the power property as the coefficient or the product property as addition, don't I have 3 of those things, either 3 times the log base B of R, or I'm adding 3 of them together? So the only reason the product property or the power property exists is because it's basically just product property, right? If I have the same number being multiplied by itself, it's like having 1 of them plus 2 of them plus 3 of them. So if I had log base 6 of 36 squared, I really have 2 times the log base 6 of 36. This one I could actually evaluate out in my head. What is the log base 6 of 36? So isn't this really 2 times 2, or just the number 4? Right? So you're allowed to evaluate a log and then multiply by the coefficient. 36 squared would have been too big of a number for me to evaluate in my head. So sometimes using the property, it allows you to break it down and evaluate it without needing a calculator. Up here, I don't know the log base 4 of 3. That's still a calculator problem. But I know the log base 4 of 2, right? That's just 1/2 because it's the square root of 4. So sometimes it helps you and sometimes it doesn't. The change of base formula is considered a property of logs. So even though we don't need this on our calculator anymore, it's nice to know that whatever base you have, you can take the common log of x and divide by the common log of the base, and those are equivalent expressions. So we used to need this for our scientific calculators because that's as much of a log as we could do. So over here, it would just like be taking the log of 9 on our calculator and dividing by the log of 6 instead of doing that change of base on our calculator. So it just allowed you to use calculators. But now we have a more sophisticated calculator. And then before they had scientific calculators with a log button, they had tables. So like when my parents were in school, they had a textbook with a log table. So you'd have to look up the log base 2 of 3 in the table of values and use that as your, abbreviated decimal or rounded decimal. All right, so I'd like you to just take a look quick at 1, 2, and 3 at the bottom and try to decide for yourself if those are true or false based on the properties at the top. And we'll go over them in just a minute, but we're ready to kind of go over them and see if they were true or false. What'd you say for number 1? Is that the property? No, what's wrong with this? So this is false. What would this have had to been over here so that I'm allowed to split it up into the 2 natural logs? That would have had to have been multiplication, right? This would have to be x times 2 for them to be able to break it up into the 2 logs. Natural log and common log have the same properties. So even though I'm writing natural log here, we know that's just log with a base of e. So ln is just an abbreviation for log with a base of e. So these logs have the same properties no matter what the base is. And number 2 was true, right? Because b cubed is b cubed. And number 3, what did you say? Should also be true, right? Because this you can think of as x times x, or you could think of it as 2 log base 5 of x's, right? So to me, that's true. All right, so the back part of this is practicing with the properties from the front. So right now, it might not seem like, why would I ever need this? It seems pointless, but we need to know the properties to do the next step. So this is just getting you familiar with the properties. So let's just do one from each section together so that you know what to do. So on number 4, you're just figuring out which expression on the right is the simplified version of number 4. So what property are you going to use on number 4? What am I going to do to simplify this into 1 log? What would I actually do? So I'm taking a log and I'm adding another log. So what can I do to the stuff inside, Eve? Multiply 4 times 3, so that must be the log of 12d. Does that make sense? So on 5, 6, and 7, they each match up to one of these over here. Let's just skip down to number 8. So this was kind of the old-fashioned way when they didn't have calculators. They might know what the log of 3 is, they might know what the log of 5 is, but they might not know what the log of 15 is in their table. So if you're just practicing using A and B, like what would I have to do if this was a value in my table? So For example, the log of 5, we're just representing that with a b. But if I wanted to represent the log of 15, how can I use a and b to represent the log of 15? So 15 is 3 times 5, right? So the rule is that I can take the log of 3 and add the log of 5. So I'm really taking a and adding b. So the final answer would be a plus b. So you're just trying to figure out how to manipulate the log of 3 and the log of 5 to get the number that you want. Does that kind of make sense on number 9 using the properties? So then in number 14, they want you to expand the expression. And in number 12, they want you to condense the expression. So just practicing the properties. Let's go do 17 instead. So if you're dividing and you want to split it into 2 logs, you still have a base of 2, but you're subtracting the denominators term. So the log base 2 of x minus the log base 2 of 3 would be splitting it up into 2 different logs. And then number 22, this would be now you need to condense it. So if it's addition, you're just multiplying, kind of like we did up top. So log base 7 of 12 would be the simplified answer. And then in 25, 26, 27, you could just use your calculator and do either the change of base formula or the change it on your calculator. So take 5 minutes and just try practicing those properties on the back page, and then we'll go over them together. So did we get all those answers from the top? Does that seem correct? And I don't care if you write 2a or just a plus a, just don't write a squared. A squared, or like over here, number 11, it's b plus b or 2b, but it's not b squared. So make sure that you've got it written correctly. Is that what we had for all those answers at the top? So then let's see. Down at the bottom, if you're expanding with multiplying, then it would be you're adding. Make sure you write the base every time. So log base 4 of 5 plus log base 4 of x, or log of 7 plus log of x, because that just has a base of 10. If you're going to expand, what I would do is I would write this as x times x first. So it's really the log base 8 of x plus the log base 8 of x. So you're showing that you've got 2 separate logs. I guess it's technically still correct if you wrote 2 log base 8 of x, but like seeing more than one log is good. We did 17 together. Negative 2 of something, if you thought of that as a coefficient, then you would have negative natural log of x minus another natural log of x. So that's like negative 2 apples. You have negative 1 of something minus another of something. That's how I thought of 18. 19, just be careful. The 12 is separate from the x cubed. So one way to write it would be the log base 12 plus the log of x cubed. Technically, that's 2 separate logs. So if you wanted to go a step further, you still just have the log of 12. You could write this as the log of x plus the log of x plus the log of x, or you could write this as 3 log of x, but that cube does not go in front of the whole problem. So you don't have 3 of these log 12s. You only have 1 of the log 12s. Just like in number 20, that exponent on the x doesn't go to the 4. So you've got natural log of 4 minus the natural log of x squared. So if you wanted to distribute the 2, you only have 2 of this last term. The natural log of 4 minus 2 natural log of x if you wanted to go a step further. It just says more than 1 log, so I would stop so you don't make mistakes. Same thing with number 21. The numerator you'd want to keep together and then subtracting the denominator. So like the log base 2 of 5x cubed minus the log base 2 of 6 is one way. If you wanted to go another step further, it'd be the log base 2 of 5 plus the log base 2 of x cubed minus the log base 2 of 6. Then if you wanted to go even further, you could take this x cubed and make it log base 2 of x plus log base 2 of x plus log base 2 of x. So just make sure that you're not distributing the power to anything else. 23 would just be natural log of 3y, or y times 3, right? And then on number 24, before you combine these terms, you have to bring the 2 up into the power. So this is actually the natural log of 49 plus the natural log of 3, because 7 squared is 49. Then you can multiply 49 times 3. So your final answer would be the natural log of, is that 147, I think? Does that kind of make sense? So before you do 7 times 3 and get 21, you really need to bring that coefficient up into the 7 and then combine the 2 logs. And then what did you get for the bottom one? So math log base. So when it's base 7 of 5, did you get 0.83? And then, let's see, base 17 of a half was negative 0.24. Sound right? Anyone need help typing these on their calculator? And then the log base 2 of 220 was 7.78. Does that sound right for that page?